So we're working on the synthesis of a coordination compound containing chromium as the metallic center and oxalate as the ligand. So the first thing is to have about 5 grams of oxalic acid, and to those 5 grams of oxalic acid to add 15 milliliters of distilled water, which is what I have right here, my oxalic acid that I weighed, so I have a specific amount in here with the 15 milliliters of distilled water. So now to help the acid dissolve, I'm going to put this on the hot plate. The solution is going to warm up, all the oxalic acid is going to dissolve, and then at that point I'm going to increase the temperature until the solution actually boils. So I'm still waiting for the acid to dissolve completely so I can wait for the solution to boil. So the solution is now boiling, and I'm going to remove it from the hot plate so I can begin adding the potassium chromate into the solution. So I'm going to begin the addition of the potassium dichromate into my solution of oxalic acid using a spatula and small amounts at a time. And this process should take between 5 and 10 minutes until all of the potassium dichromate is added. So the reaction between the oxalic acid and the potassium dichromate has stopped. So everything was added and everything already reacted. So now I'm going to warm up this solution again. So the solution is on the hot plate, and I'm going to warm the solution up until it boils. Once it boils, I'm going to remove it from the hot plate so we can start adding that third reactant that we still have, which is the potassium oxalate. So now that my solution containing the oxalic acid and the potassium dichromate is boiling, I'm going to remove it from the hot plate so I can begin adding the potassium oxalate. So while this solution is still hot, I'm going to start adding the third reactant. We can start to combine, and while we're doing this, at some point we're going to heat up the solution again, not for it to boil but to keep it warm while the potassium oxalate is reacting. I have the reaction on the hot plate, and I'm still adding the potassium oxalate. We have to make sure that we keep the reaction warm, but that it's not boiling while we still have some solid potassium oxalate in there. While I'm waiting for this here, still adding the potassium oxalate, finishing up actually. I already have set up my solvents that I'm going to be using to wash the crystals. It's pure methanol, and then we have a mixture of methanol and water, 50-50 methanol water in there in an ice bath. So we want to have the solvent cool, because the lower the temperature, the less chances for the solvent to actually dissolve some of the crystals that we're going to be getting here. So here we have the warm solution containing all three reactants, and now everything is added in there. So in this step we have to be careful that the volume of the water doesn't decrease, right? When you're warming up the solution to add the potassium oxalate, we have to keep watching this. If the volume starts decreasing, you can just add small amounts of water to the solution, just to make sure that the solution does not dry entirely. So the reaction was kept warm, right, not boiling at all in this step, until all of the potassium oxalate dissolved. And now I'm going to remove the beaker from the hot plate, and I'm going to wait for the temperature to go down until it's close to room temperature. Now that I can feel that the reaction temperature is close to room temperature, I'm going to add in here 4 milliliters of methanol. But the methanol that I'm using is not the one that I'm cooling here in my ice water bath. It's methanol at room temperature. So the next step is to transfer our beaker containing the reaction to an ice bath to help the crystallization process. So with the beaker in the ice bath, I'm going to stir and I'm going to scratch the sides of the container to help with the crystallization process. So we're going to keep this here for about 15 minutes.